In this video, we will discuss trigonometric limits by substitution, part 1. These limits are of the type limit ft as x approaches a, where ft is a trigonometric function and a is pi, pi by 2, pi by 3, pi by 4, pi by 6, etc. While solving these limits, we come across terms like sin pi by 2 plus minus h, which can be expanded as sin pi by 2 cos h plus minus cos pi by 2 sin h. Now sin pi by 2 is sin 90, which is 1, cos pi by 2 is cos 90, which is 0, 0 into sin h will be 0, so this reduces to cos h. Or cos pi by 3 plus minus h, which will be cos pi by 3 cos h minus plus sin pi by 3 sin h. Now cos pi by 3 is cos 60, which is half, sin pi by 3 is sin 60, which is root 3 by 2. Sometimes the values of a will be pi by 2, 2 times pi by 2, 3 times pi by 2, 4 times pi by 2, etc. or in the form pi by 2, pi, 3 pi by 2, 2 pi, etc. When the values of a are in this form, then instead of using the formulae which we have used here, we can use a shortcut method, and we will understand that method at the time of solving actual limits. Solve limit cos x divided by x minus pi by 2 as x approaches pi by 2. If we put x equals pi by 2, the denominator becomes 0. So we have to solve this limit by substitution. As x approaches pi by 2, we will substitute x equals pi by 2 plus h. As x approaches pi by 2, h approaches 0. See here, as x approaches pi by 2, if we put x equals pi by 2 will get cancelled with this pi by 2 and h will be 0. Therefore, as x approaches pi by 2, h approaches 0. Now, we will find out the value of x minus pi by 2. We have x equals pi by 2 plus h. We will take this pi by 2 to the left hand side, so it will become x minus pi by 2 equals h. Now h approaches 0 and x minus pi by 2 equal to h. These two values we will use in the next step. So our limit will be cos pi by 2 plus h. See here, in place of x we have put pi by 2 plus h, and in place of x minus pi by 2 we have put h. Now we have to find the value of cos pi by 2 plus h. First we will find this value by the addition formula which we have understood. Cos pi by 2 plus h will be cos pi by 2 cos h minus sin pi by 2 sin h. Now cos pi by 2 is cos 90, which is 0, and sin pi by 2, which is sin 90, which will be 1. So this term will become 0, so the answer will be minus sin h. Now we will find the value of cos pi by 2 plus h by another method. See here, the leading coefficient of pi by 2 is 1 here. 1 is an odd number, so cos will get converted into sin h. Next, pi by 2 plus h is an angle pi by 2 plus something. Therefore, this angle will lie in the second quadrant of this coordinate system. In the second quadrant, as we know, sine and cosec ratios are positive. Here it is cos, so it will be negative. Hence, its value will be minus sin h. Now see, this minus sin h and this minus sin h both are same. We will use this value in the next step, so our limit will become minus sin h over h, which will be minus of limit sin h over h as h approaches 0. We have seen earlier that this limit is 1, so the answer will be minus 1. Solve limit 1 minus sin x divided by 2x minus pi whole square as x approaches pi by 2. Here if we put x equals pi by 2, 2 will get cancelled and pi minus pi will be 0. The denominator will become 0. So we have to solve this limit by substitution. As x approaches pi by 2, we will substitute x equals pi by 2 plus h. Now, as x approaches pi by 2, h will approach 0. How? Because if we put x equals pi by 2 here, then pi by 2 will get cancelled and h will become 0. Therefore, we can say that as x approaches pi by 2, h approaches 0. Next, with the help of this substitution, we will find the value of 2h minus pi. So, we will multiply this expression by 2. So, it will be x into 2, 2x. 2 into pi by 2 will be pi itself, and 2 into h will be 2h. And we will have 2x minus pi equals 2h. Now, these two important changes we will use in the next step of our limit. So the limit becomes 1 minus sin pi by 2 plus h. See here, in place of x we have put pi by 2 plus h, and in place of 2x minus pi we have put 2h whole square. In the next step, we have to think of finding value of sin pi by 2 plus h. For this, we will use a shortcut method. Here, the leading coefficient of pi by 2 is 1, which is an odd number. Therefore, this sign will change to cos h. Next, pi by 2 plus h is the angle which lies in the second quadrant. And in the second quadrant, this sign will be positive. Therefore, the positive sign will be introduced to cos h. Therefore, sin pi by 2 plus h will be cos h. We will make this change in the next step. So in the next step, we will write 1 minus cos h. Now, we will multiply numerator and denominator by the conjugate of 1 minus cos h. So the next step will be multiplied by 1 plus cos h over 1 plus cos h. Now we will multiply the numerator and denominator separately. So in the next step we will get 1 minus cos square h in the numerator. According to the identity that we know, a minus b into a plus b is equal to a squared minus b squared. In the next step, we will write in place of 1 minus cos square h, sin square h. According to the identity that we know, sin square h plus cos square h is 1. Therefore, 1 minus cos square h is sin square h. In the next step, we will write this 1 upon 4 in the beginning of the limit, and we will write this term in a neat fashion like sin h over h whole square, and we will write a separate limit for this part. like this. Now we know that the limit of this part is 1 squared, and in this limit we will put h equals 0, because we know that as h approaches 0, h is not equal to 0. So therefore in the next step we will get 1 over 1 plus cos 0. Now cos 0 is 1. So therefore in the next step 1 over 4 multiplied by 1 over 1, which is this one, and cos 0 is 1. So 2 into 4 will be 1/8. So the value of our limit will be 1 over 8. Solve limit sin x minus sin a over x minus a as x approaches a. If we put x equals a here, the denominator becomes 0. So we have to solve the numerator. We will solve the numerator by the formula sin c minus sin d equals 2 cos c plus d by 2 sin c minus d by 2. Here the subtraction of two terms has been converted into product of two terms. So the next step becomes two cos c plus d by 2 sin c minus d by 2 c minus d by 2 upon x minus a. In the next step, what we will do, we will bring these two below this x minus a and write x minus a over 2. Now this x minus a over 2 is same as sin x minus a over 2. Now we can write two separate limits, one for this term and another for this part. So in the next step we will write limit of cos x plus a over 2 multiplied by limit sin x minus a over 2 divided by x minus a over 2. Now as x approaches a, x minus a approaches 0 and x minus a over 2 will approach to 0. So therefore this whole limit will become 1. So in the next step we will write here in place of x we will put a. So it will be cos a plus a over 2 and this limit is 1. So the next step will be 2a over 2. 2 will get cancelled and only a will remain. So cos a will be the answer. Solve limit cos x minus cos a divided by root x minus root a as x approaches a. If you put x equals a here, denominator becomes 0. So first we will multiply numerator and denominator by the conjugate of this, which is root x plus root a. So in the next step we will write root x plus root a divided by root x plus root a. In the next step we will carry out the product of the denominator only, which will be according to a minus b into a plus b, which will be a squared minus b squared. So in the next step we will get square of root x is x minus square of root a is a. Next we will expand this part according to the formula that we have. cos c minus cos d equals minus 2 sine c plus d by 2 sine c minus d by 2. So in this case, this is c, this is d. So this is cos c minus cos d. So we will write minus 2 sine c plus d by 2, c plus d by 2 sine c minus d by 2. In the next step, we will take this 2 below this x minus a and write the limit as so we have x minus a over 2 in the denominator, and in the numerator we have this term sine x minus a over 2. So we will make a group of these two terms and write one limit, and a group of these two terms and write another limit. So in the next step we will write minus now here, as x approaches a, x minus a approaches 0 and x minus a over 2 approaches 0. Therefore, this whole limit will be 1. And in this case, we can directly substitute x equals a. So once we put x equals a here and x equals a here, in the next step we will get see a plus a is 2a over 2, that will be a, and root a plus root a will be 2 root a. See in the next step, a plus a will be 2a, 2a divided by 2 will be 2. So it will be just sine a. See, this is sine a. And root a plus root a will be 2 root a, which will be 2 root a. And this minus sign will remain as it is. So the answer is minus sine 2 root a. Solve limit cos x minus root 3 sin x over x minus 6x as x approaches pi by 6. If we put x equals pi by 6, the denominator becomes 0. So we will solve this limit by substitution. So we will put x equals pi by 6 plus h. See here, x is approaching to pi by 6. Therefore, as x approaches pi by 6, h will approach to 0. If we put x equals pi by 6 here, pi by 6 will get cancelled with this pi by 6, so h will become 0. Therefore, we say that as x approaches pi by 6, h approaches 0. Now, from the substitution x equals pi by 6 plus h, we will find out the value of pi minus 6x. We will multiply throughout here by 6. So x into 6 will be 6x. 6 into pi by 6 will be pi. And 6 into h will be 6h. Which implies pi. Now we have to find the value of pi minus 6x. So what we will do, we will bring this 6x to the right hand side. So it will become pi minus 6x. And this 6h we will send to the left hand side. So it will become minus 6h. So pi minus 6x will be minus 6h. So we have got two changes to be made in the next step, which are h approaches 0 and pi minus 6x equals minus 6h. So in the next step we will write these changes. See here, in place of x we have written pi by 6 plus h. In place of x we have written pi by 6 plus h, and in place of pi minus 6x, see here pi minus 6x, we have written minus 6h. Now we have to find the values of cos pi by 6 plus h and sin pi by 6 plus h by the formula that we have. First we will find out the value of this by the formula cos a plus b equals cos a cos b minus sin a sin b, and the value of sin pi by 6 plus h by the formula sin a plus b equals sin a cos b plus cos a sin b. Now we will find the values of cos pi by 6 plus h and sin pi by 6 plus h separately. So first the value of cos pi by 6 plus h, it will be cos pi by 6 cos h minus sin pi by 6 sin h. Now cos pi by 6 is cos 30. Cos 30 is root 3 by 2. Sin pi by 6 is sin 30. Sin 30 is 1/2. So the value of cos pi by 6 plus h will be this thing. Next we will calculate this part, which is root 3 times sin pi by 6 plus h, which will be, according to this identity or formula, it will be root 3 times sin pi by 6 cos h plus cos pi by 6 sin h, which will be root 3 times. Now sin pi by 6 is sin 30, which is half, cos pi by 6, which is cos 30, which is root 3 by 2. Next, root 3 into half will be root 3 by 2, and root 3 into root 3 will be 3 by 2. So this will be the value of root 3 sin pi by 6 plus h. Next we will write the whole numerator together by using these two values. So the numerator becomes see here. So this is the first part, this one, okay, minus root 3, the second part, this one, okay. Now root 3 by 2 cos h minus root 3 by 2 cos h will become 0. So what remains is minus half sin h. See here, minus half sin h, and minus of 3 by 2 will be minus 3 by 2 sin h. Now this is minus half, and 3 by 2 is nothing but 1/2. So minus half plus minus 1/2, that will be minus 2. So this will be minus 2h. We will make use of minus 2h in the next step. So the limit becomes minus 2 sin h divided by minus 6h as h approaches 0. Now minus 2 divided by minus 6 will be 1/3, and this limit sin h over h as h approaches 0 will be 1. So the final answer will be 1/3. Solve limit cosec x minus 1 divided by pi by 2 minus x whole square as x approaches pi by 2. If we put x equals pi by 2, the denominator becomes 0. So we will solve this limit by substitution. So as x approaches pi by 2, we will put x equals pi by 2 plus h. As x approaches pi by 2, h approaches 0. Next, with the help of this substitution, we will find the value of pi by 2 minus x. So we have x equals pi by 2 plus h, we need pi by 2 minus x. So we will bring this x to the right hand side, which will become minus, and we will bring this h to the left hand side, which will become minus h. So therefore we will have pi by 2 minus x equals minus h. See here, pi by 2 minus x. Now we will use these two changes in the next step. See here, in place of x we have written pi by 2 plus h, and in place of pi by 2 minus x we have written minus h. Now we have to find the value of cosec pi by 2 plus h. We will use shortcut method. Here the leading coefficient of pi by 2 is 1, which is odd. Therefore cosec will turn into sec h. Now pi by 2 plus h is pi by 2 plus something. So this angle will lie in the second quadrant. In the second quadrant, sine and cosec are positive. Therefore sec h will be positive. So we will use this sec h in the next step. Here we have sec h minus 1 divided by h square. Now we will multiply numerator and denominator by the conjugate of sec h minus 1, which will be sec h plus 1 divided by sec h plus 1. Now we will carry out the product of the numerator according to the identity a minus b multiplied by a plus b equals a squared minus b squared. So that will be limit sec square h minus 1 divided by h square multiplied by limit 1 over sec h plus 1 as h approaches 0. Here we will use the identity sec square h equals 1 plus tan square h. So therefore sec square h minus 1 will be tan square h. So in the next step we will write, in place of sec square h minus 1 we will write tan square h. In the next step we will write tan h divided by h whole square. Now tan h divided by h as h approaches 0 will be 1, and here we will substitute h equals 0 because we know that as h approaches 0 h is not equal to 0, so it will be sec 0. Now sec 0 is 1 upon cos 0. Cos 0 is 1, so sec 0 will be 1. So in the next step we get 1 plus 1, 1 half, and the final answer will be 1 half. So this is all about part 1 of the trigonometric limits by substitution. In part 2 we will discuss more variety of such problems. If you liked our video, please click like and share this video. Subscribe to this channel. Thanks for watching and have a nice day.